9.5 billion kilometers from where you are sitting right now, something is glowing in the dark that should not be glowing at all. It is not a light. It is not a signal in the way science fiction has taught you to imagine one. It is a single, narrow band of infrared radiation, invisible to the human eye, sitting at exactly 113 microns on a wavelength chart. A chart that, until a few months ago, no scientist on Earth had ever seen produce a mark at that precise location. And yet, there it was, twice, on two different worlds that have no business sharing anything at all. One of those worlds is Titan, a moon so thick with atmosphere that its surface pressure crushes down harder than the deepest parts of an ocean trench. The other is Pluto, a frozen, airless-seeming speck at the edge of the solar system where the sun is nothing more than a bright star. Nothing should connect them. And yet, the James Webb Space Telescope found the exact same fingerprint stamped into the light coming off both of them, and nobody, not the scientists who found it, not the review panels who checked their work, not the specialists who spent weeks combing through decades of laboratory data, nobody can tell you what is making that mark. This is not a rumor. This is not a leaked document or a whistleblower or a cover-up. This is a paper submitted for publication, sitting in the open scientific record for anyone to read. And it says, in careful, restrained scientific language, that an unknown substance exists on the surface of two worlds separated by more than 1 billion kilometers, and that after searching through the known chemistry of the outer solar system, researchers could not find a single documented compound that explains it. When you strip away the sensational YouTube titles and the manufactured conspiracy language that so much space content likes to hide behind, what you are left with is something far stranger than fiction. A real, unresolved, unexplained detection, sitting quietly in the peer review pipeline, waiting for someone to figure out what it means. To understand why this matters, you have to go back first to what we thought we knew about Pluto, because almost everything about this story is a slow unraveling of assumptions. For most of the 20th century, Pluto was treated as a dead rock, a frozen leftover, a world so far from the sun that nothing interesting could possibly be happening on its surface, orbiting alone in the dark, demoted eventually from planet to dwarf planet, as if the universe itself had decided it did not matter enough to keep its old title. Then, in July of 2015, NASA's New Horizons spacecraft did something no human-made object had ever done. It flew within 12,000 kilometers of Pluto's surface after a 9-year, 5 billion kilometer journey, and in the space of a few hours, it tore apart almost every assumption scientists had made about the tiny, distant world. What the spacecraft found was not a dead rock. It was a world with mountains of solid water ice rising as high as the Rockies, a world with vast, smooth plains of nitrogen ice arranged into strange polygon shapes, constantly turning over in slow motion like a lava lamp running on frozen gas instead of heat. A world with glaciers, with what looked like dunes, and hanging above all of it, wrapped around the entire planet in delicate, layered blue bands, was something nobody had expected to see at all. A haze, stretching more than 300 kilometers into the sky, far higher and far more structured than any atmospheric model had predicted. It was beautiful, and it was completely unexplained. Pluto's atmosphere is almost nothing, a thin whisper of nitrogen and methane, thousands of times thinner than Earth's. There should not have been enough material up there to create a haze that visible, that structured, that persistent. But there it was, glowing pale blue in New Horizons cameras, and it immediately became one of the strangest unsolved puzzles to come out of the entire mission. Even the way that haze was structured defied easy explanation. It was not a single, uniform layer draped over the planet the way clouds sit over Earth. New Horizons cameras picked out more than a dozen distinct layers, stacked one on top of another like sediment in rock, each one thinner than the last, extending upward for hundreds of kilometers into a sky so thin it barely qualifies as an atmosphere at all. Mission scientists studying the images back on Earth described feeling almost disoriented by what they were seeing. A delicate, structured, almost architectural sky, wrapped around a world that everyone had assumed would look like nothing more than a scarred, frozen ball of rock and ice. It did not look dead. It looked, if anything, like it was breathing. A scientist named Xi Zhang, working at the University of California, Santa Cruz, looked at that haze and made a bold prediction 2 years later in 2017. He proposed that the haze was not just a cosmetic feature, a pretty layer sitting quietly above the surface, but that it was actually running Pluto's entire climate. He argued that these microscopic haze particles were absorbing sunlight, heating up, and then radiating that heat back out into space in the mid-infrared, acting almost like a planetary thermostat, cooling Pluto's atmosphere in a way no other atmosphere in the solar system was known to work. It was, by his own admission, a crazy idea. Many of his colleagues were skeptical, and there was a very simple, very frustrating problem standing in the way of proving it. No instrument on Earth, or in space at the time, was sensitive enough to actually detect that faint mid-infrared glow from something as small and as distant as Pluto. The prediction sat there, unconfirmed for years, a hypothesis with no way to be tested, waiting for a telescope powerful enough to see it. That telescope launched on Christmas Day 2021. The James Webb Space Telescope did not orbit Earth the way its predecessor Hubble does. It was sent almost 1.5 million kilometers away, to a gravitational balance point called the second Lagrange point, where it now sits behind a 5-layer sunshield the size of a tennis court, permanently shadowed from the light and heat of the sun, Earth, and Moon, cold enough and stable enough to detect infrared signals so faint that earlier generations of astronomers could only dream about them. And when its operators finally turned its mid-infrared instrument toward the Pluto-Charon system, they ran immediately into the same problem that had haunted ground-based astronomers for decades. Pluto and its enormous moon Charon orbit so close together and appear so close together from a telescope's point of view that their thermal signals blur into one smeared blob of light. For years, nobody could cleanly separate what heat was coming from Pluto and what was coming from Charon. Webb was never actually designed with Pluto in mind. Its primary mission, the reason it cost billions of dollars and took more than 2 decades to build, was to look back toward the very edge of observable time, to catch the faint, stretched light of the first galaxies that formed after the Big Bang more than 13 billion years ago. That it could also be pointed backward, so to speak, toward the frozen edge of our own solar system, and used to solve a very human-scale mystery about a dwarf planet's atmosphere. It says something about just how versatile an instrument this telescope turned out to be. Its mid-infrared instrument, known simply as MIRI, was built to detect wavelengths of light so faint and so long that they are functionally invisible to almost every other telescope humanity has ever built, pointing that instrument at something as small and as distant as Pluto, a world that, from Webb's vantage point, appears only as a barely resolved point of light, was, in its own way, pushing the observatory close to the edge of what it could actually do. Webb's instruments were finally precise enough to pull the two signals apart. And when the data came back, split cleanly for the first time between the two worlds, Zhang's decade-old prediction was not just confirmed, it was confirmed almost exactly as he had described it. The faint infrared glow of Pluto's haze matched the model almost perfectly. Researchers involved in the study said it themselves. In planetary science, it is unusual for a hypothesis to be confirmed this cleanly, this quickly, sometimes within just a few years of being proposed. A new paper, published in Nature Astronomy in June of 2025, laid it out formally. Pluto's atmosphere runs on a mechanism unlike anything else observed anywhere else in the solar system. The haze does not just sit above the surface, it actively controls the temperature, the energy balance, the entire climate of a world nearly 40 times farther from the sun than Earth is. Scientists began calling it, plainly, a new kind of climate, not a variation on something we already understood, something genuinely new, and the implications of that reach far beyond Pluto itself. Zhang and his colleagues have pointed out that this haze-driven climate mechanism might not be unique to one small, frozen world at the edge of the solar system. Neptune's giant moon Triton, another icy distant body with a thin nitrogen atmosphere, could plausibly be running on a similar principle, and so, in a different way, could Titan, with its thick orange smog of organic haze permanently blotting out any direct view of its surface. More strikingly still, some researchers now believe the same kind of haze physics may hold a mirror up to Earth's own deep past. Billions of years ago, before oxygen ever built up in our atmosphere, early Earth is thought to have been wrapped in its own haze of organic particles, produced by sunlight interacting with a methane and nitrogen-rich sky, not unlike the one currently sitting above. Pluto. If that haze helped regulate early Earth's temperature the way Pluto's haze regulates its own, then understanding what is happening today, 9.5 billion kilometers away, may end up telling us something about the very conditions that allowed life to gain a foothold on our own planet in the first place. A small, frozen, demoted world at the edge of the solar system, offering a distant echo of Earth's own forgotten childhood. And once you start looking at Pluto that closely, the strangeness does not stop with the haze. The same observations revealed that Pluto's paper-thin atmosphere is not just sitting there passively. It is leaking. Slowly, constantly, gas molecules are escaping from Pluto's atmosphere out into space. That alone would not be shocking. Small worlds with weak gravity lose atmosphere over time. But what happens to that escaping gas is where things get genuinely strange. Some of those molecules do not simply drift away into the void. They travel across the gap between Pluto and its giant moon, Charon, and they land there, depositing themselves onto Charon's surface, chemically transforming its ice as they settle in. This is why Charon's poles are stained a dark, reddish color, a slow billion-year exchange of atmosphere between a dwarf planet and its moon, a kind of planetary breathing that has never been observed happening anywhere else in the solar system. Two worlds, locked in a gravitational dance, quietly trading atmosphere back and forth in a process scientists are only now beginning to map in detail. Webb's data also drew out a sharper contrast between the two bodies than anyone had managed before. Charon itself, it turns out, has essentially no atmosphere of its own. Its surface is dominated by plain water ice mixed with traces of ammonia-based compounds, a chemically simple, comparatively quiet world sitting right next door to one of the strangest atmospheres in the solar system. And yet, even Charon is not entirely passive in this story. Its darker, reddish polar caps, long visible even in older telescope images, are now understood to be the direct fingerprint of that stolen plutonian gas. Methane molecules that escaped Pluto's gravity, drifted across the gap, landed on Charon's poles, and were slowly transformed by sunlight and radiation into a dark, reddish, organic residue called tholin, the same general class of material thought to color the hazes of Titan and to have coated much of the early, prebiotic surface of Earth billions of years ago. A moon, in effect, wearing a faint stain left behind by its own planet's dying breath, reapplied particle by particle for millions of years. It was in the middle of chasing down these haze measurements, while researchers were painstakingly separating Pluto's thermal signal from Charon's, while they were mapping out methane ice here and water ice there, nitrogen deposits in one region and darker organic material in another, that the far stranger detection surfaced. In May of 2023, Webb captured something researchers had never had access to before, a high-resolution mid-infrared spectrum of Pluto, stretching across a huge range of wavelengths, from roughly 5 microns all the way out to 27. It was the kind of dataset planetary scientists wait their entire careers to get their hands on. A spectral fingerprint of an entire world, rich enough to pick apart individual chemical signatures buried inside it. Somewhere in that flood of data, at a wavelength of exactly 113 microns, there was a dip, a small, precise notch cut into the spectrum where light was being absorbed by something on Pluto's surface, a signature roughly 4 to 5% deep, unmistakably real and unmistakably unidentified. That alone might have been filed away as an interesting anomaly requiring further study, one small mystery among thousands generated by a telescope this powerful. But then a separate team working through Webb's earlier archived observations of Saturn's giant moon Titan found the exact same signal, the exact same wavelength, the exact same absorption feature, sitting in the spectrum of a completely different world, more than 1 billion kilometers away from Pluto, orbiting a completely different planet. On the surface, Titan and Pluto could not be more different. Titan is wrapped in an atmosphere so thick it presses down on its surface with 1.5 times the pressure of Earth's air at sea level, 50 times the atmospheric pressure Pluto has, if Pluto can even be said to have meaningful pressure at all. Titan has rivers. It has lakes and seas, though not of water, of liquid methane and ethane, the only other place in the entire solar system besides Earth known to have stable liquid on its surface. Pluto, meanwhile, is a frozen, nearly airless world roughly half Titan's size, sitting in a completely different neighborhood of the solar system entirely, with almost nothing in common with Saturn's giant moon except one thing: nitrogen and methane chemistry drifting somewhere in their thin outer atmospheres. And now, this one unexplained absorption line, identical down to its wavelength, mysteriously present on both. Researchers did exactly what good scientists are supposed to do when they find something they cannot explain. They went hunting through the literature. They pulled up decades of laboratory spectra, comparing their mystery signal against every documented ice and organic compound known to form in these kinds of cold, irradiated environments. Ethane, ethylene, acetylene, propane, benzene, hydrogen cyanide, compound after compound after compound, cross-referencing wavelength against wavelength, band against band. None of them matched. Not one recorded absorption feature in the published scientific record lined up with the exact position of this mysterious 5. 1 to 13 micron dip. Whatever is producing the signal has not been cataloged. It does not appear in any laboratory spectrum currently on record for the frozen, irradiated ices of the outer solar system. That does not mean scientists are without theories, and this is the part where the story gets genuinely fascinating rather than simply frustrating. Several plausible candidates have been proposed, though none confirmed. One possibility is a class of organic compounds called allenes, whose molecular structure produces absorption bands in roughly the right region of the spectrum. Another is benzene, but mixed with other molecular species in a way that shifts its usual signature just enough to explain what Webb is seeing. A third possibility involves keton, or certain compounds that form when methanol ice is bombarded by radiation over long periods of time. Exactly the kind of slow, cosmic ray-driven chemistry that both Pluto and Titan experience constantly, sitting as they do at the frozen edges of the solar system with only the thinnest of atmospheric shields to protect their surfaces. And there is something else worth sitting with for a moment. The signal is not identical on both worlds. On Pluto, researchers found the absorption line is roughly 3 times wider than the one measured on Titan, even though its depth, the actual strength of the absorption, is remarkably similar on both. somewhere in that 4 to 5% range. That difference in width matters. It is not just decoration in a spectral chart, it is a clue. Scientists first wondered whether temperature could explain the difference. Pluto's surface sits somewhere between 30 and 60 degrees above absolute zero. Colder, generally, than Titan's surface, which hovers closer to 90 or 95 degrees above absolute zero. For most ices, the general rule is that absorption bands get wider as temperature rises, not colder. If that rule held here, Titan's warmer surface should have produced the wider signal, not Pluto's. But it is the other way around. The colder world has the broader absorption feature, which directly contradicts the simplest explanation and forces researchers towards something more complicated and more interesting. The leading theory now centers not on temperature, but on radiation exposure. Pluto's atmosphere is so thin that cosmic rays, high-energy particles streaming in from across the galaxy, penetrate directly down to the surface, burying themselves centimeters, sometimes tens of centimeters, into the ice. Titan, by contrast, is shielded by an atmosphere 50 times thicker than Pluto's, one that absorbs the vast majority of that incoming radiation before it ever reaches the ground. If Pluto's surface is being irradiated far more intensely than Titan's, that constant bombardment could be breaking apart chemical bonds, forming new molecular species, scrambling the local molecular environment into something more chemically diverse and disordered. And that disorder, that structural chaos at the molecular scale, is exactly the kind of thing that would broaden an absorption line the way researchers are seeing on Pluto's surface. In other words, the same mysterious substance may exist on both worlds, but Pluto's harsher radiation environment may be reshaping it, scrambling it, diversifying it into a wider spread of molecular configurations than the more sheltered version sitting on Titan. It is an elegant explanation. It is also, its authors are careful to admit, still just a hypothesis. As of this reporting, the Pluto-Titan detection has not yet completed peer review. It exists as a preprint, publicly posted for the scientific community to scrutinize, argue over, and eventually confirm or dismantle. That is not a weakness in the story. That is what real science actually looks like while it is happening. Not a finished answer delivered from on high, but an open question, sitting in public view, with researchers around the world now racing to run their own laboratory experiments, irradiating their own ice samples, trying to reproduce a 113 micron absorption line in a controlled setting on Earth, so they can finally put a name to whatever is sitting out there on the surfaces of two worlds separated by more than 1 billion kilometers of empty space. And this is precisely why the far-fetched cover-up version of this story does such a disservice to what is actually happening. Nobody had to hide anything. Nobody needed to invent a secret. The real story here required no embellishment at all. A telescope so sensitive, it can read the chemical fingerprint of sunlight bouncing off a world 9.5 billion kilometers away, confirming an 8-year-old hypothesis about a haze that runs an entire planet's climate, uncovering an atmosphere that leaks itself onto a neighboring moon, and then, almost as a side effect of all that careful, painstaking work, stumbling onto a chemical signature that matches nothing else in the recorded history of planetary science. If anything is being kept from the public, it is only by the ordinary, unglamorous pace of peer review, the months and years it takes for a claim this strange to be checked, rechecked, and checked again before anyone is willing to put their name behind a final answer. So where does that leave us? A telescope built to look back toward the birth of the universe has, almost as a footnote to its main mission, turned its eye toward the closest, coldest, strangest corners of our own solar system, and found a puzzle nobody predicted. Two worlds, wildly different in almost every measurable way, are quietly sharing a chemical secret that no laboratory on Earth has yet managed to name. Teams of scientists are right now, as this is being written, running experiments, freezing gases, irradiating ice samples, trying to recreate in miniature the exact conditions that exist on the surface of a dwarf planet at the edge of the solar system and a giant moon orbiting Saturn, all in pursuit of a single narrow dip in an infrared spectrum that refuses, so far, to match anything we already know. Whatever that substance turns out to be, its discovery will not come from a leaked document or a whistleblower or a secret NASA vault. It will come the way almost every real breakthrough comes. Slowly, carefully, argued over in journals nobody outside the field usually reads, until one day a name finally gets attached to that stubborn little notch at 113 microns, and an unsolved mystery at the edge of the solar system quietly becomes solved science. Until then, it remains exactly what it is right now. Open, unresolved, and spectrum in hand, undeniably real.